are concerned, it is nothing but the combination of real part as well as the imaginary part. Now when we say imaginary part, that concept we get from this numerical calculation, that is, suppose if you have square root of minus 4. Now if we want to calculate square root of minus 4, so as far as the real numbers or the real plane is concerned, we don't have any solution for this. Now to calculate such calculations, just to simplify such quantities, a new concept has been defined, and that is termed as, or a new number has been defined, which is termed as imaginary quantity. Now when we say imaginary, it starts with I, and it is assigned a special value such that I square it is equal to minus 1. Now I stands for imaginary, I square is given a value, and that is equal to minus 1. The mathematicians have assigned a value for this such that I square is equal to minus 1. Now if we consider I square is equal to minus 1, then I can write this quantity as 4I square, because minus 1 it is replaced by I square, so it is square root of 4I square. Now I square is minus 1, so it remains same as this. Now using the concept of the square root, we can simplify, and this will become your plus minus 2I. So now we can write this is square root of 4I square, it is plus minus 2I, where I stands for imaginary quantity. Similarly we can say square root of minus 9. So if you say square root of minus 9, so it again becomes plus minus 3I, because again minus 1 it will be replaced by what? I square, and once it is 9I square, so that will be calculated as plus 3I minus square root of 9. That means it is, we are writing square root of 9I square, and square root of 9 square, that is plus minus 3I. So this way we calculate all these quantity. Now we already have the concept of the real numbers. Now we have introduced a new number, and that is imaginary number or imaginary quantity. The combination of this real number as well as the imaginary number, that is termed as the complex number. So combination of real as well as the imaginary, that gives us the concept of the complex number. Complex number, it is represented by Z. So we can write Z is equal to, suppose, A plus IV. We can write Z is equal to A plus IV, because it is combination of the real number as well as the imaginary number. Here A and B are real numbers, but when this IB, so this signifies the imaginary quantity, and this still it is the real quantity. So A, it is the real quantity. If you talk of only B, so B is also the real quantity, but once it is with this I, it means it represents that this IB, it becomes an imaginary quantity or imaginary number. So this plus this, that makes the complex number, and as far as the standard format is concerned, we represent it as Z. So Z is equal to A plus IB. We call A as the real part and B is the imaginary part, because it is the imaginary part of this imaginary quantity. So B is the imaginary part and A is the real part, and combination of this, that makes the complex number Z. Complex numbers, they always occur in pair. So if you have, suppose Z is equal to A plus IB or C plus ID, or suppose any other quantity, you can say X plus Z is equal to X plus IY, and so on. So either way we can represent all this. So complex number always occur in pair. So if Z is equal to A plus IB, its pair, it is termed as the conjugate of that complex number. So conjugate of this complex number, it will be, suppose, Z bar, we represent like this, and this is termed as the conjugate of the complex number, represented as Z bar, such that this Z bar, it is equal to A minus IB. A minus IB, one here is with the plus sign, another here is with the minus sign. Whenever a complex number occurs, let us say A plus IB, the other part definitely it will be there, and that is A minus IB. So this is your complex number, this is the conjugate of this complex number, and which is equal to A minus IB. We can also term it either way. If this is z, then this will be z bar. So that way we can also pronounce, if z is equal to a minus ib, then z bar, its conjugate, it will be a plus ib, and so on. And the main concept is the sign between the real part and the imaginary part gets changed. Here if it is plus sign, here it is minus, here it is minus, so here it will become plus as far as the complex number and its conjugate is concerned. Now if you consider, suppose z plus z bar, the addition of these two complex numbers. So before we go to that, we can see this property. A is called the real part of the complex number, represented as real of z. That you can say real of z. Okay, and B, the imaginary part of the complex number that we have just discussed, and that is imaginary. IM stands for imaginary of z. So these are the standard representation of this complex number. Now equality, when we say these two complex numbers are equal, let us say z1 and z2 are equal. Suppose z1 is equal to a1 plus ib1 and z2 is equal to, let us say, a2 plus ib2. If we say z1 is equal to z2, that means real part of this, it will be equal to real part of the another number, and the imaginary part of first, it will be same as the imaginary part of the second. It means a1 is equal to a2 and b1 is equal to b2. So here you can see two complex numbers are said to be equal in their real parts, and imaginary parts are separately equal. If a plus ib is equal to c plus id, that means a is equal to c and b is equal to d. That's what we have here. A1 is equal to A2 and B1 is equal to B2. Real part should be equal to real part, imaginary part, it should be equal to imaginary part. If these two conditions are satisfied, then we say that the two complex numbers are same. Now here we can have certain properties of the numbers, like suppose a plus I0. That means what? If you have the real number as a, so you can write this as a plus I0. Means its imaginary part is how much? 0. So here this a, it is a real number, but it can be considered as a complex number, because such that its real part is a and imaginary part is 0. Imaginary part it is 0, so this a can be considered as a complex number. This is what this statement wants to narrate. Can be considered as a complex number whose imaginary part is 0 and the real part is equal to a. Similarly, you can say complex numbers with imaginary part 0 are said to be purely real. So imaginary part is 0, so obviously we can say that this is purely real number. We can say that it is a complex number having imaginary part as 0. We can say that it is a purely real number. Purely real number. So purely real number. Similarly, you can write 0 is equal to 0 plus I0. This here, the real part is 0 and the imaginary part is 0. So 0, it is also a complex number. So this can also be considered as a complex number. I hope these things are clear. So these are just the symbolic representation, and that we can always do. Now I is equal to square root of minus 1 is called the imaginary unit that we have just considered. I square is equal to minus 1. You can have some algebraic example and how to calculate as far as the value of I is concerned. I square is equal to minus 1. This is the standard. Now we can generate any power of that, I square, I to the power 4, I cube, and all that. So here if you do that, so I square is equal to minus 1. I cube can be represented as I square into I, because we have value of I square. So all the terms it should be represented in terms of I square. So I square is equal to minus 1, so that becomes your minus of I. Minus 1 into I minus I to the power 4. You can write it as I square whole square. I square minus 1, so minus 1 whole square, that becomes plus 1. So that way we can calculate. I to the power 5. Because we always try to change it as a factor of I square, because we know the value of I square. So I to the power 4, you can write I square whole square into I. and I square minus 1 whole square means plus 1 into I, so that makes it, that is minus 1 whole square plus 1 into I, so it becomes I. And this you can also represent it as, because just now we have calculated I to the power 4, that is 1, so it can be represented as I to the power 4 into I to the power 4, we know it is plus 1, so it is plus I. So this way we can simplify as far as calculation based on I is concerned, that imaginary quantity is concerned. Here you can see in some of the quantities in larger order, I to the power 10. So I to the power 10, here you can see all this. Directly you can say it is I square to the power I to the power 10, I square to the power 5, and I square is equal to how much? Minus 1. So minus 1 to the odd power, that becomes minus 1, so it is minus of 1. Okay. So here you can represent this way, directly you can represent this way, and you can simplify. So any order, reduce it to in the form of I square, replace I square by minus 1, and you can simplify whatever be the order of this. You can see I to the power how much? 1995. So 1995, so again we can simplify, and finally because it is odd, I square to the power what? Some even number, that will become plus 1 into that I. So from there you will, because it is odd here, so I square to the even power, that will become plus 1. Next it will be with the minus sign, and from there you will get this minus of I. Now this I here, you can write it as how much? 1 upon, can we write this as I is equal to 1 upon minus I, because minus of I. So here if you consider I into minus I, that becomes how much? Just have this cross multiplication, minus of I square, and minus of I square is equal to how much? Plus 1. If you consider this, so this becomes minus of I square, having this cross multiplication, and that should be proved to 1, and I square is minus 1, minus minus plus 1, so plus 1, it is equal to plus 1. So I can be represented as 1 upon minus of I. 1 upon I, it is equal to minus I. Multiply the numerator and denominator by I. So this is I upon this I. So this becomes your I upon I square, I into I square. This is minus 1, so it is I upon minus 1, and that becomes your minus of I. So 1 upon I, it is minus of I. I, it is equal to 1 upon minus I. So wherever necessary, we can make use of all these concepts. So now as far as the conjugate is concerned, that we were discussing, now you can see the certain property of this. A plus IB and A minus IB or A minus BI, they are the conjugate of each other, are said to be the complex conjugate of each other. Now here, if you consider this, if A plus I is represented by Z, then its conjugate, it is represented by Z bar. That's what we have already discussed. Now, if Z is equal to A plus IB, then ZZ bar, that will be equal to how much? 2A. So when you add two complex number, the final relation gives what? Only the real part. The imaginary part gets eliminated. So simply we get this real part. Similarly, if you multiply them, if you have suppose ZZ bar, if you multiply that, so ZZ bar, it will be A plus IB into A minus IB. You can say IB or you can say BI. There is nothing wrong in that. So it is equal to A square minus B square minus 1, because here this is equal to your A square minus B square I square. A plus IB into A minus IB, simple, using the simple algebraic concept, we can, but I square is equal to minus of 1, minus minus, that becomes plus, so that it becomes A square plus B square. So from there directly we can get it, A square. So again this becomes what? A real quantity. So product of the two complex number, complex and its conjugate, that gives a real number. Addition also, it gives the real number, and the imaginary parts gets eliminated. Now here, if you see this, real of z is equal to real of z bar, because z, if it is equal to suppose a plus ib, then z bar is a minus ib. Real of z and real of z bar, that is same, it is equal to a. So real of z, it is equal to real of z bar, and that can be considered as what? Z plus z bar by 2, because when we add these two, this gets eliminated. Always you get twice of either this or twice of this. So it means z plus either z or z bar, that will be equal to how much? This plus this divided by 2, because when we add this becomes 2 times, again getting it back, we have to divide it by factor 2. So that's what here is done. Imaginary part, it will be how much? Z minus z bar upon 2i, because if you subtract these two, this will get eliminated and you will get twice of ib. So twice of ib, so that 2 has to be eliminated as well as I has to be eliminated. So finally you get imaginary of z, z minus z bar upon 2i, real of z or real of z bar, that is equal to z plus z bar upon 2. So this or this, there is nothing to remember in this. Wherever needed, we can always derive these quantities, whatever is required, and we can substitute and we can proceed further. So that way you can consider as far as the complex and its conjugate is concerned. Now see the algebraic operation on the complex number. When we say algebraic operation on the complex number, how the complex numbers are added, subtracted, multiplied as well as divided. So here if you consider, suppose z1 is equal to, let us say, a plus ib and z2 is equal to suppose c plus id. Now you want to add them. So if you want to add them, z1 plus z2, so simply real part, it will be real with the will be added with each other, and imaginary with the imaginary. So here this becomes a plus c plus this I b plus d. A plus C plus I b plus d. So this is just the addition of the complex number. Similarly, if you want to subtract them, as far as subtraction is concerned, z1 minus z2. So again a minus c plus this I will be common, b minus this d. So we can write a minus c plus I, if we take common, this becomes b minus d. This minus this, and we just separate the real part as well as the imaginary part. So a minus c plus I b minus d. We can again multiply. As far as multiplication is concerned, it is as equivalent as the simple multiplication in case of simple algebraic relations. There is nothing, no difference, and there is nothing to worry about it. So here if you multiply these two, z1 into z2, so z1 into z2, it will become a plus ib into c plus id. Each and every term of this, as we do in simple multiplication in case of real numbers, each and every element of this and this, that will get multiplied. So here a will be multiplied by c, so you can write this as ac plus ad, any iad, plus ibc plus I square bd. Now we will simply separate the real part as well as the imaginary part, and we will rearrange it. So AC, I square is equal to how much? Minus of 1. So if it is minus 1, so this will become minus BD. So this part and this part is real. Here it is IAD, we can't eliminate I from here. Here it is IBC, that cannot be eliminated. So these will be kept together, and these two terms will be kept together. So we can write this as AC minus this BD plus I AD plus BC. So this becomes your real part of this multiplication, and this becomes the imaginary part. So AC minus BD plus IAD plus BC. In some of the books, some of the writers, some of the teachers, they will tell you, remember this. There is nothing to remember. This is just for your understanding. When two complex numbers are multiplied, each and every term will be multiplied as we do it in algebra, simple algebra, and we will just separate the terms. So real it will be kept together, imaginary it will be kept together, and we will simply rearrange this. This is the way that we do the multiplication. Now as far as the division is concerned, so suppose here you have Z1 is equal to A plus IB and Z2 is equal to C plus ID. Now Z1 by Z2, the division. So Z1 upon Z2, it will be equal to your A plus IB divided by C plus ID. Now here, only one concept we have to use before we start simplifying. Once you have term in the denominator, wherever you see the terms in the denominator, our intention is always to simplify the denominator. And simplifying denominator is such that try to make it as or convert it into a real number, if it is possible. So to make this denominator a real number, what should we do? We should multiply this with the conjugate, because we know A plus IB into A minus IB, it is always A square plus B square, which is a real number. So that way the first statement or first step is always simplify the denominator, try to make it or convert it into a real quantity by multiplying with its conjugate. So when we multiply with its conjugate, and we don't have to change the value of this entire quantity, that also we have to take care. So when we are multiplying with the conjugate of this to the denominator, same multiplication we have to do in the numerator. So we will multiply the numerator and denominator by the conjugate of this denominator. So C minus ID. Okay, now again, as we have done the multiplication, each and every term here it should be multiplied, and the denominator again it reduces to a real quantity. So here you can see that will be equal to your A plus IB into C minus ID divided by C square plus D square. C plus ID into C minus ID, that will be C square minus I square D square, I square minus 1 minus minus, that will become plus, so that C square plus D square. Now as we have just done in the multiplication, each and every term of this, it should be multiplied here. Separate the real part as well as the imaginary part in the denominator, then your entire expression will be what? The real part in the numerator divided by this, because it is already a real quantity, plus I into imaginary part in the numerator divided by this. So that way you can separate it. Suppose after multiplication of this, it is coming as x plus I y divided by C square plus D square, as just now we have done. So real part value, let us say it is coming as x, it is just a symbolic representation of that quantity by x, and the imaginary part it is coming as y. Now you will get this expression. Now again, if you need to simplify it further, then we always try, in case of complex number, we always try to represent it in such a way that real part and imaginary parts are separated. So real part plus the imaginary part or the minus imaginary part, that way we always try to represent. So this can be represented as x upon C square plus D square plus I y upon C square plus D square. So this is your real part and this is imaginary part. So this way we can separate real as well as imaginary. So here you can see all these calculation and that way. So there is nothing to remember in all this. These are only for your understanding. Try to understand and try to use the concept wherever it is necessary. As a formula, there is nothing as a formula I should remember this or I should remember this. Now, so here you can see the multiplying the numerator and the conjugate of that. So we have done that as far as the division of the two complex numbers we are concerned. Now see this statement here, a complex number can be 0. The complex number do not possess the property of order. A complex number can be 0, that we have just discussed, 0 plus I 0. So that is 0, its imaginary part is 0 and its real part is also 0. Now you can see this statement, the complex number do not possess the property of order. Property of order, that means here, if suppose you say 5 plus 3i greater than 2 plus I, this has no relevance. Whether this is greater or this is less, that way we can't say, because real part is greater than real and this imaginary part is greater than imaginary. So we can't say that this is greater than this 2 plus I. So that way we can't have this kind of following the order as far as the complex number is concerned. Now see the representation of the complex number. So complex numbers, it can be represented geometrically, it can be represented as far as the vectors are concerned, and it can be represented trigonometrically. So one by one we will discuss this, how the geometrical representation takes place, how the vector representation takes place, as well as how the trigonometrical representation takes place. So this we will do in the next video. Thank you.